Hello, welcome back. In the last class, we discussed about the contents of the syllabus in signals and systems, and we also looked into the various units in signals and systems. In this class, let us discuss about the definitions like what is a signal, what is a system, and how we can classify the signals. So let us take an example here. So I'm just taking an example of how voice signal uh, can be amplified so that the amplitude of the uh, signal will be strengthened. So here you can see that a microphone actually captures the voice input, and that is given to an amplifier, and the amplifier is going to increase the strength of this weak voice input, and an amplified version of this signal is given to the speaker. So this is a simple mechanism which will increase the strength of a voice signal. What you notice here is the voice input here, as you know, it is a physical phenomena. Okay, depending on the variations in the voice, you will have the different magnitude, and this physical phenomena is supposed to be converted into an electrical signal. So a transducer needs to be used here. So a microphone, as you know, converts uh, a physical signal into an electrical signal. So the output that I get here is an equivalent electrical signal of the voice input, and by just increasing the strength of this by using an amplifier, we can obtain an amplified signal. So what you notice here is a physical phenomena which is converted into an equivalent electrical signal, and you know this electrical signal will be a function of time. As the time changes, the magnitude of this electrical signal changes. And what amplifier here is doing is it is manipulating on the input signal, and it increases the strength of the input signal. So this is actually a function that it performs and yields an amplified signal. Okay, so now we can represent this entire setup by using a block diagram where I have the input signal which is being manipulated by using a system to yield an output signal. Okay, so we have already introduced two terms here. One is called the signal, and the other is called the system. So there are some keywords like physical phenomena. You have an electrical signal which is a function of time, and the amplifier is actually manipulating on the input, and it is performing a function which in this case is increasing the strength of the signal, and it yields another signal here. Okay, now let us try to define these terms, signal and systems, in formal terms. Okay, so what is a signal? uh, so as we have seen in the previous example, it is defined as a function of one or more variable. Okay, in my example it is one variable, but you can have more than one variables also. For example, if the input signal is an image, it will be two dimensional or two variables. Okay, and you know this voice signal is going to convey some information. So the signal is conveying some information, and it is actually conveying the information about the nature of a physical phenomena. Okay, so formally a signal can be defined as a function of one or more variables which conveys information on the nature of a physical phenomena. Okay, so then what is a system? System is an entity, and it manipulates one or more signals. So in our case, it is manipulating only one signal, that is the electrical equivalent of the speech signal, and it accomplishes a function. Okay, in an amplifier, the function it accomplishes is increasing the strength of the signal. So this is a function that is going to be accomplished. and it yields an output signal or a new signal. Okay, so what you get on the output in this system is an amplified signal. Okay, so formal definition of a system is it is an entity that manipulates one or more signals to accomplish a function, thereby yielding a new signal. Now, depending on the variables on which this function is uh, depending, we classify signals into one dimension and multi-dimension signals. For example, uh, in the case of a speech signal, the signal is a function of one variable, that is, it is a function of time. So it is one dimensional signal. If it is an image signal, as you know, an image is a two-dimensional signal. So it will be something like f of x comma y. So it is two-dimensional signal. Suppose if it is a video signal, then the signal will be not only the function of x and y, but it also the function of another variable t. As the time changes, the contents of the video signal changes. So it is a three-dimensional signal. So that means this comes under the multi-dimensional signal, and speech is an example for one-dimensional signal. So depending on the independent variable, t here is independent variable, as similarly x and y here are independent variable. F depends on this t, so it is called a dependent variable. So depending on the number of independent variables, we classify signals into one dimension and multi-dimension. Okay. See, the processing on the signal can be either done by using analog signal processing method or by digital signal processing method. These days, most of the processing is done by using digital signal processing. So what do we understand by the term analog signal processing? As the name itself says, the processing will be done by using some analog elements. For example, good examples for these analog elements is the resistor, inductor, capacitor. So if I perform any processing by using such analog elements, it's called analog processing. In digital signal processing, we actually use digital multipliers and digital adders. So the processing is done on a digital signal and the results are yielded as a digital output. In such case, it is called digital signal processing. So these are some of the